Hi everyone. So here we are going to do the Laplace transform of this piecewise function. And we're going to use the step function to help us out along the way, along with the Laplace transform of the step function. So to start this problem, I have already written the first step, which is essentially get the function, rewrite the function in terms of the step function using those intervals you see here. Just to go over how that works is sine of t we want to be true for the interval 0 to pi over 2, and when you look at the step function where a is 0 and the step function where pi over 2 is the a, to the left of 0 here you'll have 0, to the left of pi over 2 you'll have 0, and to the right of 0 you'll have 1 for the step function where a is 0. To the left this will be 0 of that, so you'll just have sine t from essentially 0 to pi over 2, and then after pi over 2 this will be 1 based off of this again, and this will be 1 also, and you'll have 0 times sine, which is just nothing, and that will create the sine of t function only on the interval from 0 to pi over 2. Similarly with these other ones, cosine t minus 3 sine of t, multiplying by the difference of the step function u sub pi over 2 minus u sub pi. To the left of pi over 2 this is 0, to the left of pi this is 0, to the right this is 1, to the left of, that is 0, but to the right that'll be 1, so after pi this will 0 out, but between pi over 2 and pi, which is this interval, you will have the function cosine t minus 3 sine t. And then similarly, the last plus 3 cosine of t times the step function of u sub pi of t to the right only, and that's why we only have that, because we only need the right, and that to the right of that is 1, again based off of this part right here. And that is it for that step. So now we need to do some distribution and simplification and maybe substitution to help us find the Laplace transform of the function. So I'm going to distribute the terms. Starting with the sine t, and then I move on to the cosine t minus 3 sine t. I'm going to do the cosine t first. Then distributing the minus 3 sine t. Plus 3 sine t u sub p pi of t, plus the last term, 3 cosine t times u sub pi of t. Okay, and then a lot of terms here, so I think we can combine a couple, this term and this term, as well as I think this term and this term. So, alright, once we do that, I think that's all the like terms we have. Highlight them so I can do it correctly. And then I will add them together. Simplify a little bit. Sine of t times u sub 0 of t minus 4 sine of t times u sub pi over 2 of t, and then plus the cosine of t times u sub pi over 2 of t, plus 2 cosine of t times u sub pi over t, and then finally, plus the last term, 3 sine of t times u sub pi t. Okay, so now that we've simplified a little bit. It's not looking too good yet, but we're working on it. And now we want to try to manipulate this so we can use the Laplace transform and evaluate it. So we do need to look at some identities down below to help us work this out. You can find these identities on like a trig sheet, or what I did was I knew that I wanted to rewrite these functions in terms of t minus pi over 2 and t minus pi, so I manipulated it on a graphing calculator, which you can do the same thing. But either way, these are true identities, and we can use them to help us rewrite these terms in terms of this, so we can take the Laplace. Sine of t times u of 0 of t, that one's okay because 0 is a, t minus a is t minus 0, so it's just going to be t. The 4 sine, or negative 4 sine t times u sub pi over 2, that is not written in our form. We need it to be in one of these. But again, we can see, for example, sine t is the same as cosine t minus pi over 2, so we can actually rewrite that, which I will do. So we have sine of t times u sub 0 of t minus 4 cosine t minus pi over 2 times u sub pi over 2 of t. And then similarly, cosine of t, we need to be t minus pi over 2. I don't know if it's cosine. I think it's actually going to be, we're going to have to substitute that in, right? So negative cosine is the same as sine of t minus pi over 2, so we can rewrite that as minus sine of t minus pi over 2 times u sub pi over 2 of t. And then similarly again, cosine of t, we're multiplied by the step function u sub pi, or where pi is a, we need to look over here, and we do see that the negative of cosine of t is the same as cosine of t minus pi, so we can substitute that in. So minus 2 cosine t minus pi times the u sub pi of t. And then finally, this term here, we need t minus pi, and that's the opposite, so we can, again, let's write it as minus 3 sine t minus pi, u sub pi of t. And now, just to scroll back up, we now have all our functions in terms of f of t minus a times the step function at a. And now we can use this idea to help us find the Laplace of the function. So I'm going to scroll up here and continue this wonderful problem. The Laplace of a little function, f of t, is just going to be equal to the Laplace of, and I'm going to write this in front, times sine of t minus 4 times the Laplace of u pi over 2 of t cos t minus pi over 2 minus the Laplace of u sub pi over 2 of t times sine of t minus pi over 2 and where am I at? Okay, right here. Okay, minus the Laplace, oops, let me erase that, minus 2 times the Laplace of u sub pi of t times cosine of t minus pi and then minus 3 times the Laplace of u sub pi of t times sine of t minus pi. Okay. Now, that was really long, but we are almost done. Now we have written everything in our proper form. We manipulated it, so now we can essentially just use the idea of, since we know the a for each of the step functions, we manipulated the function of sine and cosine of t minus a, and now we can use this rule where it's just e to the negative as times the Laplace of little f of t. So that's nice, because using that idea, we can now find the Laplace of each. So for this first one, a is 0. I guess I'll just write it. E to the 0 s. The Laplace of sine t is just 1 over s squared plus 1 minus 4 times the Laplace of the step function u sub pi over 2. So we know a is pi over 2, so it's going to be e to the negative pi over 2s times the Laplace of cosine t minus pi over 2 is just going to be the same as if it was cosine of t, so it's just going to be s over s squared plus 1. And again, that just follows from this form we got up here. We manipulated our functions to have this f of t minus a times the step function at a, and now we're able to just manipulate it. We know our a of the step function, and now we know kind of the main function we're basing it off of, so we could use the Laplace of those. And our functions are of cosine and sine, so that makes things a lot easier too. So now I'm on the third term, right? So minus u sub pi over 2, so e to the negative pi over 2s again, times the Laplace of sine of t minus pi over 2, which, again, we know it's just a little, we can use sine of t, which is going to be 1 s squared plus 1. And then for these other ones, I'm going to do them a little faster. Minus, oops, if I don't write the wrong thing, minus 2 times e to the negative pi s. And then the Laplace of cosine is 1, or not 1 over, but s over s squared plus 1 minus 3 times e to the negative pi s times the Laplace of sine is just 1 over s squared plus 1. Whew. And then we still have to do a little more work here. Essentially just cleaning this up. We can clump some things together. E to the 0 is just 1, so we just have this 1 over s squared plus 1 term. These two right here, we can factor out the e to the negative pi over 2s, so I'm going to do that and just get minus e to the negative pi over 2s times 4s plus 1 over s squared plus 1. And then also these last couple terms right here, I could do a similar thing and factor out the e to the negative pi s. So I'm going to do that. So minus e to the negative pi s. E to the negative pi s times 2s plus 3 over s squared plus 1. And I believe I am done. Phew, that was fun, wasn't it? Hopefully that makes sense.